Okay. Today we are back in the lab on the scanning electron microscope. I've prepped a few more samples from the material that we analyzed last time on Saturday, and I'm still looking for Afrosymbella. I'm still looking through basically the same kinds of material as we did last week, but just spending a bit more time looking for specific types of Afrosymbella, and also I thought I would try to image some of these other things that are present in the samples. So I'm just going to start by focusing in on some of these other diatoms while we have them right here. This is a cool little diatom. This is got some sort of a defect in its stria right here, where they're making little triangles. Currently called Cymbella cucumis, in something in that neighborhood at least. But I think maybe it's a Cymboplura. It just hasn't been transferred, or maybe it has been transferred and I'm just not up on the taxonomy yet. So, yeah, that's a pretty neat looking little diatom. Especially the areolae on the outside, and it has sort of like very distinctly round areolae or pores right around the central area. And then as they move away from there, they become sort of like glyph-shaped, rune-shaped. And you can see, as I mentioned, they look a little bit like there's some deformation out here on the edges. And I'm just going to tweak the beam intensity. Oh. Straight in with a subscribed and a raid. Thank you. I must have came in right at the end of your stream time. We started off with a bang. Last Miles raiding with a party of 126 people. That's a crazy number of people to start off with. I've only been running for about 3 minutes now. So thanks to Last Miles, doing something cool, of course. You wanted people to see the next big geek? Well, I think they found one. And Dennis sent you. Thank you guys for coming over. Right now I'm looking at some diatoms in the scanning electron microscope, and I just fired this up right now. So also wanted to say hello out there to Pacific Plankton, and I want to wish everybody happy holidays or Merry Christmas or whatever you want to celebrate during the holiday seasons. I'm not particular. And the diatoms are a type of algae that live in any kind of aquatic systems, and their cell walls are made out of opal and silica. And so as a result, after they die, their skeleton, which is the cell walls, they're single-celled organisms, and so their skeletons get preserved. And I have these on my scanning electron microscope in my lab, and it doesn't look that great at the moment, but I promise you all I need to do is slow the beam down a little, and the quality of the image will improve dramatically. And today we're just sort of looking around some diatoms that I have from Lake Tanganyika. So we can't look at COVID through this microscope. You need an ultra high resolution scanning electron microscope to see COVID, and this is just a simple tungsten electron microscope. So you're running out of steam in a big way. Well, you just need some more of that coffee that you like to drink. And Pandemic Watch, hello. Jans, hello. And I'm going to say thanks to Last Miles. I got an emote out of that. Look at that cool emote I got. A celebrate emote. I think everything's working. So I'm just going to jump back. I'm by myself in the lab today again, of course, because my students are on break. And I never rest. I never take breaks. So I am back in the lab regardless. As I mentioned, we're looking at diatoms from East African lakes. This one is from Lake Tanganyika. So here's this diatom. Currently, I think it's called Cymbella cucumis. And it has a really cool raphe. Look at the crazy extension of this line right here. It curls in the center. They curl, they deflect in the same direction. And then big smile, right? So it curls around at the outside edge and makes a really big smile. Its friends over here that are sitting on the stage with it are Calanese. These are epiphytes. They are also diatoms, and they make two different types of valves, whereas most diatoms just make one type of valve. So these diatoms are what's called monoraphid. One of the valves makes a raphe and one does not. And you can actually see one right here with no raphe. So the raphe is this line that runs through the central area. And this one makes no raphe, and that one makes a raphe. So they usually call this the rapheless valve, and this is the raphid valve. But these are probably the same species. Some sort of Calanese, close to Placentula linearis. And there are, in the world, tens of thousands of described diatom species, and I just know a few really good ones. Maybe that's an underestimate. I know more than a few. But the ones from East Africa are the ones that I'm particularly interested in for these projects that I'm working on right now that are taxonomic in nature. So some of these, like this one, is again a Calanese. You can see where the raphe would have gone. This is where the raphe would have fit in this little area that doesn't have any holes on it. So these little holes are called areolae. They are in lines called striae. This thing right here, the silica is just solid, is called a sternum or sterna, if there's more than one. You can see right here, this one has a sterna through the middle as well. So they don't always run down the middle of the valve. If we hop over to the next diatom that we can see, this is a Calanese, which is closely related to the genus Pinularia. And I think this is probably Salicula or Schumaniana, one of those two. It's closely related to it. They have very distinct lunate or moon-shaped central area feature on the valve. A characteristic of both Pinularia and Calanese is that the striae are composed a bunch of these really tiny lines that you can really only see in the scanning electron microscope. So these little tiny dots that we can see right here are organized into these sort of wide bands. You can see there's sort of a space between them where it's solid silica, and then there's pores and solid silica. So this part right here is usually referred to as a costi on the inside of the valve. And on the outside of the valve, these rows of areolae are referred to as striae, or stripes, basically in Latin. And this is a really cool one. Sort of peanut-shaped, a double peanut, if you like. I can rotate this image around, and I'm going to. I just need to twist it a little bit so that it goes corner to corner because, like most scientists, I have obsessive compulsive disorder with respect to keeping things organized. And that one just rotated a little bit out of my field of view, and I twisted it the wrong direction, so I need to make it like -15 maybe. Here we go. So now it goes corner to corner, and the advantage of corner to corner is it maximizes the diatom on the field of view so that we don't waste any of our precious photographic space. And I'm just going to spend a little bit of time getting the focus perfect, or as close to perfect as I can get. And then I'll be able to hop back over to chat and see what you guys are saying. So apologize for not being able to manage everything at once. I normally have some very lovely assistants, my students who usually hang out but can't be here. And I'm going to set the speed to 7, so it's a nice slow scan across the diatom and draw the picture, and then I'll be able to talk with you and perhaps answer some questions if you have any. I want to fix the brightness and contrast first, so one last step before I'll be able to hop over there and sort of see what's going on. Again, you can see the raphe on this diatom is this sort of dark line, and it starts to hook here and bends around off of the valve face. So diatoms are composed of 2 valves. Their whole frustule has 2 valves, and we are currently looking at the valve face, which, if you think of it sort of like there's 2 valves, you could see it this way or this way. So we're currently looking at the outside of one of the valves, and I'm just going to collect that image, and then I can see what chat's been up to. So let's see. OX80H says pretty cool. The holes seem quite symmetric, and symmetry is actually one of the things that diatoms are well known for. And the curvature of the central hooks, that's the usually called the proximal end of the raphe, the one that's in the center. And the distal end of the raphe is the one that's basically on the outside edge here. So we usually refer to the middle 2 curled pieces as the proximal end of the raphe, and this is the distal or the far end of the raphe, the one that goes to the apex. So you saw an infographic. This is Ribozoid. Says, I saw an infographic of how small COVID is. It is crazy small. Yeah, well, it's a virus, so it's going to be very small. Diatoms are, of course, very pretty. And Comrade Bubbles, hello, how are you doing? I'm going to give a shout out. I really missed the shout outs already. Let's do one for Comrade Bubbles. Very pleasant young lady who likes to talk about, read books and play games, and discuss how we should be better to each other. And Pacific Plankton, my good friend, should get a shout out, as well as Last Miles. So I'm just going to try to get those in right now while I still have the ability to, before things get crazy. Let's see. The next question down. It's like Smedley Whiplash's mustache. Yes, also. This is ultra interesting. Thank you, the fish pool. A few good diatoms. How are things? Jonathan Gamecast. We should also send out a shout out to Jonathan, who casts his games. We're doing well. I was in the lab working on some stuff from White Sands National Park, National Monument, with another science colleague, and so I thought, even though it's close to the holidays, I'll try to squeeze in another SEM stream. And Cinnamon, hello. It's nice to see you again. Are those like integral membrane proteins, the dots? No. So everything that you're seeing is made out of silica. It's part of the outside of the diatom. The cell walls are made out of silica. So the dark dots are actually just holes, like literal holes that you could see through if you had the ability to get down into that really sort of small size. So Jonathan's Gamecast asked, do we know biogeographically where early diatoms evolved, or was it so long ago that oceans would have been in different places, or does that mean much? So diatoms very likely evolved in the Jurassic. We don't know for sure. There's some early things that look kind of like diatoms from the Jurassic, and they would have been in the Jurassic oceans. So they started in the oceans and worked their way into the land, and there have been multiple what we think of as invasions of the marine organisms into the terrestrial landscape. So the more than one time have they basically migrated from ocean settings into freshwater or lacustrine settings. And my good friend Andy Alverson actually studies this, looking at them. So another diatomist friend of mine, he doesn't stream or anything, but if you're interested in it, he'd be a good person to check up with. This is sample 93. And this is... Sorry, I just need to do a little bookkeeping on my end. Calanese. I'm going to call it Salicula, but it very likely is Schumanian or something related to that. I'll have to look it up later. And then we can move over to something else. There's a bunch of cool stuff on this slide. I guess it's more of a stub than a slide. This thing down here used to be called Rhopalodia, would now be Epithemia. Here's an internal view of it, and this is an external view of that same thing. There's a bunch more of our Calanese friends. You'll see a lot of these Rhopalodia, Epithemia things. They're quite frequent in the sample. And if we keep sort of scanning outward, zooming outward, this is a fragment of a sponge spicule. And like Calanese, these are all these little oval things that you're seeing are Calanese. And the sample was probably collected from vegetation of some sort, which is where Calanese tend to dominate because they are what we call epiphytic. In other words, they live on top of another organism that's a plant. There's a whole bunch of cool stuff, as I mentioned, in these samples. There's a bunch of things that are only found in Africa. This, for example, is a diatom that's only found in Africa. And this diatom was described by my friend, colleague, Pat Koselik. And let's see, maybe 325, 330. So I'm trying to figure out how to rotate it to... That might be too much, but we'll give it a shot. Yeah, just a little too much. So I want it to be corner to corner. I'm still not quite there. With the really big things like this, it sometimes helps to have it as close to perfect as you can get it. Because you need to make it as big as possible. So this diatom is currently called Gomphanema. I have a suspicion that it might not belong in Gomphanema, or if we look closely at it, might need to be moved into a different genus. A monstrous diatom, so very large in size. And if I zoom into the central area, you'll see that it has, here's a really simple straight, they look like maybe butterfly antenna, kind of endings to the raphe, the proximal ends. And this diatom has something called a stigma, or stigmoid, which is this little tiny hole that's separate from the rest of them. And then these are the striae, which are composed of what we would call lineolate areoli. In other words, they're little lines that create rows when they're stacked up together. Diatoms have sort of like an endless number of geometrical shapes and designs that you can see. And to me, the textures are actually just amazing to look at. So I love looking at diatoms in the scanning electron microscope. I think it's visually, they're very pleasing organisms to look at, what we scientists sometimes call charismatic. Trying to be like, use fancy words to describe, how we feel about the diatoms. It's a very charismatic diatom. And let's see, I probably could get that focus just a little bit tighter, which is something that I'm always fighting with. And this particular diatom, as I mentioned, is currently in the Gomphanema genus. So we're going to slow that down. We'll take a picture just like this of the central area of this guy with the cool structures all visible. and then I can come back to chat a little bit and talk some more. I know I missed a bunch of comments. As somebody had asked if I've described any species, and the answer is yes. And I'm currently working on describing species from this sample as well. So I'm particularly focused on right now the genus Afrocymbella, which is not, well, potentially could be where this thing that we're looking at goes, but I don't think it ultimately will go there, but maybe. And because it does have a stigma, and on the inside the stigma is linear, which is not supposed to be a characteristic of Gomphanema, but I don't think it's been separated out yet. But it wouldn't be a new species in that case. It would be an old species that would just be moved. But we do have some species that are in the sample that are very likely to be new, and I've had some of them on the stream briefly. So I think that the quality of that image is actually quite good. And I'm going to snap that photo. And I can pop back over and see what people have been saying. So, let's see. They're not quite bivalves, but they have two valves, two parts. That's what the name diatom means. So di means two, and atom means parts. The really small ones that it doesn't matter. They're all holes, yeah. They're not quite as tiny as a virus. Let's see. I gave all my shout outs, and then are these ancient fossilized organisms, or how old? These particular samples are actually modern. Well, they were collected in 2017 or 2016 by my friend Itzi from Lake Tanganyika, but I do quite frequently look at ancient diatoms. I think this diatom is Gomphanema killamai or Gomphanema Patrick? I don't know. I have to look it up. It's one of those two. It's a really big diatom. Pat Kaselik identified it. And I also want to say hello to Yeva, a fellow diatomist here. Del Max, how you doing? Dressed up in my hoodie. It's not actually cold in here. But let's see. Someone should give a shout out to Del. Or Del, give a shout out to yourself. You can do it. So that's on your shoes when you run across the field. I don't understand. The microscopic life is amazing, yes. Oh, somebody already did give Del a shout out. Del and Pacific Plankton gave each other shout outs. And Lujan, or wait, is it Luhan? Another diatomist, friendly diatomist is here. So some of my peers are around to watch. Oh, you got a nice holiday card in the mail. That's good, Del. I did send out some Christmas cards with my... it took a long time to write out all those addresses. I think I spent an entire day working on it. So, yeah. You know, there aren't that many unfriendly diatomists, to be honest. We're all pretty... Oh, also Kalathon got a Christmas card because he got a sticker. Alright. I'm going to stick this one on there. Gomphanema. I think it's Patrick. I think it was named after Ruth Patrick, the very famous Ruth Patrick. But I could be wrong. And then we'll do one zoomed out like this. And also I want to zoom in on the foot pole. So these asymmetric diatoms like this actually have a head pole, what's called a head pole and a foot pole. So this area up here is referred to as the head pole, or this apex. And this one down here, the foot pole. And you can see it's shaped like a submarine, right? It's asymmetric, but it's basically got a wider part and a skinnier part, and in this one there's a pointy end and a rounded end. But the cool thing about it is that down here is where there's a whole bunch of little holes in the valve, what's referred to as an apical pore field, a series of little holes that it squeezes out some polysaccharide material to attach to substrates. So these diatoms can move around a little bit using their raphe, which is this part, and they can also squeeze some snot out through the bottom of the valve, at the bottom of the frustule, and they use that to create little stalks that they grow on. And Gomphanema very commonly live that way, with one end attached and the other end waving around like a fan, right? So, and they sometimes will grow in colonies, the fan-shaped colonies, where all of the bottoms are attached, and then as they split, they just make the colony a little bit wider. So that's just part of their life habit. This is a very pretty diatom. And I'm gonna snap that shot as well. I got some nice views of the inside of this diatom last time, and I've got a really nice view of the outside of it this time. So I'm very happy I've got the entire thing characterized. I saw some pictures that Pat Kaselik had of it, and they weren't that great. And I don't know how many he has, so I thought maybe I could make a Christmas card out of these and send them to Pat. We'll see. Until their army is large enough for conquest. Well, there's not very many diatomists in the world, so I don't think that we're going to ever get a very large mass. We did have so Luhan was mentioning that there was a diatom party on the solstice. So on Monday, all the diatomists around the world gathered in Zoom meetings hosted by the International Diatom Society for Diatom Research, and we all hung out and chatted in little rooms on Zoom, and you're supposed to bring your own drinks. I went to the European one and I went to the North American one because I have friends in both places, and the European one, when they mixed the rooms up, I almost ended up with the same people every time. I think maybe a total of the last two times there was only like one new person in my group, so they didn't do a great job of randomizing it for me in advance. But I actually thought it was nice. The North American one happened through my dinner, so I sort of snuck food in while the stuff was going on. Yes, apical pore field is the right answer. Do they have a nervous system? Timus, no, they don't, because they are single-celled organisms, so they don't have any sort of nerves, and they're also algae. So polysaccharide is just like goo, yeah. So they are phototactic. So Pandemic mentioned this, that they will move along gradients. They will also move along nutrient gradients sometimes, light, but they're definitely at least phototactic. So I don't know if it's always the same kind of polysaccharide, but that's a good question, Del. I don't study the biology of diatoms, so a lot of people ask me biology questions, and I'm like, we need to ask one of my friends. I don't really know the answers to those kinds of questions. Yeah, I don't know. They just made it only available to people who were in the society, I think, or their friends, but it would have been nice if they'd probably opened that up to the public. But I think it's also the first time they were doing it, and they weren't sure like how many people were going to be there. So I guess Del and Pacific are answering your questions, hopefully, Timus. And Yeah, that's a diatomaceous earth would be a good idea for a network. Yeah, I mostly look at the dead diatoms. I look at their skeletal material, and I mostly am looking at them for, in most cases, I'm looking at them for their purpose of being a tool in paleoecology. Hi, Global. How are you doing? So, you can't just look at things that are dead, though, in my opinion. You kind of need to see what they look like in real life. And also, one of the problems is, of course, working in East Africa, there's not flora guides for a lot of stuff. So it actually is very helpful to see the modern organisms for me so that I can kind of figure out what do the ancient ones look like. I'm going to go to the head pole because it's got a really weird structure on it. Is that a spine? I didn't realize it had a spine. That is super weird. I don't know. I'll have to look. I think there's another one with an external view on one of these stubs. What is going on right there? It looks like there's a spine on the outside edge of it. Maybe it's just a deformed bit of the skeleton. It's definitely protruding upward, though. I suppose I could tilt it if I needed to and look at it from the side, but I think I've ever seen a accompaniment with a spine on it. So that's super weird. It's just got like a little tooth sticking up right there. Sometimes you got a little snaggle tooth sticking out, and there's not much that can be done about it, I guess. This is pretty cool. Snaggle-toothed. It's a unicorn. Yeah, isn't that cool? It's got one horn. I also take a lot of macro photos of things with my camera, and I really like insects. And one of the things I like to image is dragonflies, because they'll just sit there and let me get close and take pictures of them. And there's a dragonfly that's called a unicorn dragonfly. That's its common name. And it just has like a tiniest little horn in the middle of its head. This is a much more pronounced horn, to be honest, relative to the body of the organism. The dragonfly's horn's obviously bigger than the entire diatom, but as a part of its body, this thing is actually much more distinct and pronounced. What a crazy structure. I'm definitely going to send this off to Pat and ask him what's up with this thing. Cool. Time for some sexual selection in diatoms. 1,000,000 years from now, they will all look like belugas. Maybe. Or narwhals. Yeah, I like the dragonflies. Oh, you think it's a hangnail? Could just be like, a minor protuberance. Well, I've got another one. I don't know if I have any sitting in girdle view, so it would be really nice if I found one in girdle view. We could look at the head pole and see if that's on both valves and if that's a common feature or not. But I definitely have another external view of this thing, and I want to look closely at that because that is goofy. What a crazy structure. Hope everybody's doing really well out there. Things are always crazy with the pandemic, of course, but hopefully everybody's being safe. And head pole, unicorn. I'll remember which one that is later. Let's go look at the foot pole of this thing, this beastie. So this is the foot pole. You can see it's a round in this case. They're not always, but this one definitely is. And if I get it in focus, you can really get the sense of those holes for the apical pore field, and you can see how distinctly different they are from the rest of the valve face and valve structure. So these holes are areolae. They're lined together in stripes. You can see those stripes right here a little more easily, I suspect. This is the raphe, and in the case of Gomphanema, the raphe typically rolls through and bisects the apical pore field, which is what's going on right here. And this giant diatom has just a giant apical pore field, right? So, of course, the bigger you are, the bigger your apical pore field probably has to be if you're a diatom and you attach. So, I'm going to go ahead, get that thing lined up. So I made some of these stubs last time from the same sample, and they had a bunch of clay in them, and as a result I couldn't see the diatoms I was trying to see, and that's always frustrating. So I earlier today went into the lab and rinse the samples again. So I basically just shook them up a little to stir up the clay, and then I let it settle for about 5 minutes so that all the diatoms would fall out of the water column and be concentrated at the bottom. And then I aspirated and vacuumed out the top part of the sample that had the clay-rich water in it, and that clarified the water a little bit. And then I shook it up again, filled up with some more water, shook it up again, and then did that again. And basically now you can see the samples have no clay in them. So I have these really beautiful, clearly visible diatoms without junk covering them. In the light microscope, clay isn't really a problem because you're looking through the diatoms, and so if they have something on the surface, it doesn't matter that much unless there's a lot of it. You probably wouldn't even notice. But in the scanning electron microscope, because we're looking at the surface of the diatom, or whatever we put in there, we're always looking at the surface of it, and we can't see through it in the same way that you can in the light microscope. The result is, of course, that when you have a bunch of clay, you can't see anything. You see the clay. So in this case, we've gotten rid of all of that, and we can actually see the beautiful surface of these diatoms. I also normally operate the microscope sort of at 30 kV, and I lowered it down to 10 to get a little bit more of the sort of surface structure. Narwhals, yeah. Chill wiper. Hey, BTC Fly, thank you for checking in with us. And I should really go back through. There's a whole bunch of people from last mile's raid that followed. Term cap, restrained, cold blue mist, 8KS, 8M, Saturn with a 5 and a V, the fish pool, Van B. Can. Vancouver, maybe? Ollie, O80H. It's Mean Flow. Selden Blake. Muffin. Alpha Bio. Output Logic. And BTC Fly. I want to thank all of you for following. It means a lot to me. We are getting close to 800 followers. We started out about 4 months ago with like 10 followers, so I feel like there's been pretty good growth. But let's see. There's a little precipitate on the surface of that one. It's probably little silica nodules. Alpha Bio, good day. Yeah, the little raised dots, Muffin, that's what those are. They're probably, well, in diatom terms, we call those, I think they're called granules. They're basically just little bits of silica that get deposited on the surface of the diatom. We're down at the really fine scale, so that's a 5 micron scale bar. So we're really tiny little pieces on the valve face that you're seeing, and sometimes they're put there, I think, by the diatoms themselves. When they have a little bit of extra silica, they may stick some of it on the valve like that. And now I'm super excited to go look for another one of these big guys, and so I'm zooming out because I want to go see if there's another one with a horn on it, or if we can find one in a girdle view. I know I said I was looking for Afrosymbella, but this is what happens when I start working on the scanning electron microscope. There's just so much cool stuff that it's hard to, I stream for like 2 hours, and then I'm like, I wish I had another like 5 hours to sit on the SEM and do nothing else, because it's fun. So I'm going to put the beam intensity to 10 so we can scan around a little bit more quickly. And let's see if we can find another one of these big guys. And if we can't, then we'll move on. I'm pretty sure that's a Rhopalodia. That's a sponge spicule. Those are all Rhopalodias, the big things. So we're just going to roll around a little and see. There's an internal view right there, that same guy. We were looking at the outside. That's a pretty glorious internal view. You can see this is the foot pole again. That is what's called a helictoglossa. It means rolled tongue, like that. And it's at the end of the raphe on the apex. And it should have one on both the foot pole and the head pole. So that's the foot pole, rounded end. That's skinny. On the outside, we saw a stigma that was a little tiny oval-shaped hole. And on the inside, you can see that it's actually this slit right here. And then the proximal ends of the raphe, in this case, these really cool little antenna shapes, or antler shapes almost, which is actually a characteristic of Afrosymbella, and I don't think it's common for Gomphanema, which is why I think this one might be closely related to Afrosymbella. Here's another helictoglossa, and then this structure that you can see right here, this little ledge of silica on the inside, is called a septum. So it has a septum, and actually has a septum on the foot pole as well, so you can't really see the apical pore field very well. I think we could probably zoom in, you'd catch a little piece of it in here somewhere, but you can also see it on the outside. But we'll come back and look at this one in a minute. I want to go see if there's more with a horn or a girdle view first. That is a Rhopalodia. That's actually the diatom I'm looking for. Afrosymbella Muelleri. So we will come back to that one as well. Sorry. What happens when I move, if you're wondering why is it making that sort of jerky motion, it's that on the test scan Vega 3 SEM, you move by moving the mouse, and wherever the mouse is, that goes to the middle when you click it. So when you see it jump, what you're seeing is I picked something and then it jumps to that as the middle of the stage. So while it looks like it's jerking around to you in random ways, I'm actually being very selective about where I'm going with it so that I could move in a circle around the outside edge of the stub, and we're back where we were. So there's where the diatom we started with was. And they're so big, I could probably even zoom out a little farther, but the problem is that I have my working distance set at 5 millimeters. In other words, the distance between the sample and the cone where the beam comes down is set at that distance. And it limits the... Is that the same one? Yeah. It limits the ability of me to zoom out. So I'd have to actually lower the stage to get any farther out than this. Which is fine, but I'd rather not do that. So I'm going to jump over to one more sample I have where I know this thing is existing. Here it is. You can see like pretty easily that's an internal view. And there's an external girdle view, and it does have horns. Check it out. Look at the horn on both valves. Here's one, and here's one. That is goofy. I've never seen that in a Gomphanema before, and I'm definitely going to be asking Pat about this. What the heck? Okay, I did not realize that they had horns. I've seen this thing in internal views only. I think that's the problem on the SEM. I've only seen internal views, and I've never seen an external view that was clear, and I've definitely never seen it in girdle view with both valves preserved like this so that you could see the horns. Isn't that cool? That is crazy. Okay, I'm gonna take this picture. First I need to make some adjustments to the quality of the image. I guess the focal's probably okay. Speed's okay. This thing down here is a Rhopelodia, that's a Calanese, and that's a Calanese. There's one with a Raphy, there's one without a Raphy. So, as we were talking about, those are pretty common in here. This Rhopelodia thing has been moved to epithemia, but I think it's similar to Giberula, something like that. It may not be exactly the same, because we haven't looked very closely at those. So there's a possibility that it's something different. The exposure looks good. We're going to capture ourselves a unicorn. It's pretty cool. Oh, we got some new follows while I wasn't paying attention. So I4T, thank you for joining the Diatom army. And also Baby Taper. Yeah, it's good to see our success, I guess. Your OCD is shaking right now. The elusive narwhal hunt, and we discovered one. Do they just enjoy being covered in silica? I think it's for their protection. You know, I think it's meant to keep them safe from other things, the outside world. I think that's why they have the cell walls that are made in silica for Shrink 46. Alpha Bio, it's amazing how much stuff there is that we cannot see with the naked eye. That is basically my fascination in life, is the things that we would overlook. So these things are so small, they're dust-sized particles. You definitely would never see one or be able to pick it up, but they're just fantastic. And the textures on them, I think, are superb. And, you know, without the ability to zoom in on these things, I feel like, at least with the light microscope, but especially with the scanning electron microscope, I feel like we'd just be missing so much of what's going on out there. Yeah, you could spend a lifetime just scanning through like a cubic centimeter. I think that's true. I think that would be a life well spent, maybe, depending on what it is you're doing with it. And we're seeing it with electrons, yeah, which is another really brilliant aspect of this, the science and the technology, that we're able to not even use light. We're just using electrons that we're bouncing off of the surface of this thing in order to capture these images. So, yeah, pretty cool. So, yeah. Luhan's with me. These things are really weird looking, right? A carnivorous diatom. I hope not. We're going to be in bad shape if that's the case. The horn's about 1 micron in size, probably. We can zoom in and look really closely at the horn if you like. It's got a little newt. Silicas to percent shaping. Could be. Could be. I don't even understand what the spine or horn or whatever it is for. Like, that part's completely opaque to me. This thing is giant, so it's not like the spine is helping it be a little bit bigger, which is usually what people think spines are for. I have no idea what's going on with this, but it's a pretty cool little diatom. I feel like even if it's not new, I think just characterizing it and showing it to people would be pretty cool. Girdle view with horns. I'm just gonna ask Pat when I see him, or when I email him, about, like, since when did Gonfanima have horns? Since when? So it looks like the horn is roughly 2 microns long. Let's see if I can get just the horn in focus for us, because I'm kind of focused out here and my depth of field is really small. I need to, like, do this. Really just looking at the surface of that thing. I find cool stuff when you look in the SEM sometimes. Maybe every time. I don't know. Unless it's covered with clay and then you don't see anything. Hey, Mama Bon Bon, how you doing? We've got horns today. Dell's on a work call. Dell, it's Wednesday. There's 2 days before Christmas. Tell him you don't work. Yeah, Stereonella have little horns on them like that. And there's a whole bunch of, Cerarella that have horns that are kind of like that, just kind of jutting out. It's really weird. Thank you for the follow, Joe Blue. You did not know that you could take these pictures this close in real time. Yeah, well, we can, and I'm here to show it to you on Twitch. You're at the only place on Twitch where you can see scanning electron microscopes in action. Every day that I'm on, I guess I could do it every day if I felt like it, but you like worms. What kind of worms do you like? Oh, it's like a little witch's hat. Yeah. I can change the speed settings. Yeah, so it's taking a slow scan. If you feel like you're in the 80s waiting for your picture to load from the internet, that's because the slower it scans, the higher the resolution of the image. And 7 is sort of like my minimum if I want to publish this sort of, or put it on the internet as a cool picture. That's the sort of speed where I sort of need to have it in order to get a high quality photo out. So do you want to see hard metals or crystals? I could put rocks on here all day. I mean, I'm a geologist. I got rocks in the other room, but polishing up some thin sections would be okay. I could put those on here. Or we could just put some actual like crystals in. Definitely could. Haven't really done a sort of a geology stream before. We have done a bunch of biology related things. People sometimes confuse me for a biologist, but I'm actually a geologist by training. So yeah, usually when my lab assistants are around, we do cool things. We look at other stuff, like mushrooms and bees, and so many things. I can't even make a list of them. Pollen, phytoliths, flowers, beetles, hair. I don't know. We just did all kinds of stuff this year so far. Close up with horns. Well, really, it's just the one horn. It does look like a shark fin. Okay, so this is my new fascination. I have no idea what's going on with that, but I am going to do like an overview shot here. Because this is the inside of that valve, and here's 2 more valves that are laying on their side, and that's a really nice composition for a photo, because you can say, oh, this goes here, these 2 things fit together, right? But I do want to fix the focus towards this thing probably in here. Gonna do that so it's in focus, and then pretty well composed right there. Maybe I'll just happen to get it just happened to land such that it was angled correctly, which I'll take as a win. Okay, where are we? Beam here. Everything looks good to me. We're gonna take that photo. And you can see several things in the field of view around it. This guy up here, this diatom, is a Celophora. This diatom is an Encynema. That's a Calanese. That's a Rhopalodia. That's a Gomphanema. That's a fragment of a Placanese. That's a spine of a sponge spicule. Yes, I can identify diatoms by fragments as well. Let's see. Here's our Gomphanema. That's a Calanese. This is a piece of a Rhopalodia, I think. There's another piece, a little tiny piece of a Gomphanema up there. See how sharp those dots came in? That's why I did that. I want that to look really nice. The Girdle Band, the girdle view is the side view of a diatom. The structure that's right here, that's sort of weirdly shaped, is actually the girdle band. So this is a little band of silica, and oftentimes there's many layers of these between valves, and they basically are like kind of like duct tape that goes around the outside of the valves and holds them together, or allows them to expand a little bit. If they need to make new valves, they make them inside of the old one. So they would make one facing the same way as this one inside, and then make another one facing the same way as that one on the inside of this one. And then they would use their girdle bands to sort of give themselves some space internally, and then the 2 valves would just basically become separate, and we'd have two cells where we used to have one, in a process known as binary fission, or mitosis, if you like. So here's the helictoglossa, the septa on these things, and you can see the stigmoid in this case is three little slits, and here it's curling. These are the proximal raphe ends, the distal raphe ends, and striae. So you get all of the features, every feature visible right here, including our little weird horns. So Calanese, 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 Nitzia, Calanese, Calanese, Rhopalodia, 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 Rhopalodia. I identified all of them to genus for you. Crazy thing. Okay, so that's these two. And some more spines. Sponge spicules, I mean. There's some cool stuff in here. Let's see how far I can go out. So you can see when I made the stub, I put a little bit of water on the stub, and then it dries up. Basically, the water has the diatoms, sort of like an extract, I guess, with the diatoms in the water. And we can't look at wet things in this scanning electron microscope, so we have to dry them out in order to look at them. We dry them on a little metal stub that's about 10 millimeters across or something. There's another external view. There's that horn. So it's the same diatom, same features. Our little unicorn that we've been looking at. And here's another internal view of that one. And there's another one up there. This one's a little squat. This is a short version of it. And diatoms have different sizes as they change from old to young, or from young to old. They grow smaller because one fits inside of another in order to split. So they perpetually get smaller through asexual reproduction until they can't anymore, basically, and then they will switch to sexual reproduction. It's a pretty good view of the inside of that thing. There's a bunch of them on this sample, which is amazing, because usually samples where I have these things, they're uncommon or they look like trash because they're broken up or something like that. And this one is just a bunch of pristine versions of it. So pretty excited to see that. This one here's one that's broken. That's what I'm used to seeing. It's just a broken up trash version. You can see this is an internal view, the same diatom. Here's the same structures. One of the things that's kind of nice about broken diatoms is that it lets you see the actual internal structure of the cell wall. So we could zoom in, for example, on one of these things, and we might actually be able to see something revealed by the fracture, rather than just looking for pretty photos. We sometimes can actually see some of the structure that becomes visible when you break it. And I have a colleague, Dave Harwood, who would sometimes take his diatoms and then he would mount some of them separate from the rest, and then he would just rub a pencil eraser over them to break them so that he could get a view of the other diatoms sort of in fractures. This little sun-shaped guy is a Stephanodiscus. And I'm pretty sure it's Stephanodiscus and not Cyclostephanos. Really small. So I was zoomed in like crazy a second ago. I was like, why won't this focus? It won't focus because I was in really close. When you're in really close, I have to lower the beam intensity to get it to focus any better. So this is a really little Stephanodiscus. Yep. I will come back and look at that some other time, probably. When I'm not scanning for cool things. Oh, here's one. Here's one. Here's an external view. Doink. Still got a horn. And I think this is the internal view. That's a sponge spicule. There's an internal view. Oh, no, it's an external view. But you can see that the valves have been sort of squished together. And the girdle bands are stuck on the outside of this. So it's either just formed and split, and the valve is sort of recessed as a result, or it just got squished together a little bit somehow. And so it's got a bit of the girdle band stuck on the outside. It's covering over the good bits, though, which is the stigma. So I've been actually talking for a while without taking pictures, and now I feel like I need to get back to chat real quick and see what's been going on. Hopefully you're being patient with me. Trying to keep there's an external view, another external view. How is it I just got all external views this time, and last time I only could find internal views? It's so weird. There's that goofy little horn. They all have it, so it's not a fluke. It's a feature. There's another external view. There's just so many of them, it's kind of amazing. And the sample's so clean. Sponge spicule. I'm not sure what that massive junk is. Some organic gunk that didn't get digested in the nitric acid that I exposed them to. It's an ensynema, I think. Internal view. Just going to stop to get my focus correct. Sponge spicule. External view. feel like I've gone around the whole horn here. Let's go back towards the middle, and I want to zoom in on just this. I'm going to focus on this thing for just a little bit longer, and then we'll start to move around, look at some of these other things like that. I wanted to get a nice view of the stigmoids and the raphy ends in the center. Focus like pow! Okay. Cool. That's going to be a good one. Let's see what everybody's been talking about. What have you been talking about without me? I missed a bunch. Okay, I'm gonna try to catch up. Is it literally using a beam of electrons to scan the surface of this object right now? Yes. There's a SEM command if you'd like to use it. It's just !SEM, and it'll give you all kinds of information about the SEM itself, what kind of SEM and how it works. But they basically just bounce off of the surface and they're collected inside the instrument. Shrink 46, do diatoms do weird stuff on different rocks? There's some evidence to suggest that different diatoms get some of their nutrients from rocks, so they grow better on different surfaces, but still not super well known how well they might select one rock over another. I think the horns for intimidating. It's possible. Let's see. I miss using my grad school's Hitachi. Well, I don't know what to tell you, Freya. If it was in the middle of the pandemic, you could come use my SEM if you needed to. Very sharp image, looks great. Are all of the controls for this SEM digital? Yes. I don't have to do any physical anything. And most of them are with the mouse, which is really nice. So in my original SEM, I used to use a JEOL with the Kodak film inside of it, and it had mechanical doodads you had to turn. So you ended up like doing this while you're trying to look at the image over there. None of that. It's a nice SEM. Let's see. Calanese goose. Okay. What is the picture on the side? Those are, if you're not talking about me, those are a little slideshow of SEM images we've collected. Some on the show, many actually just prior, but they're things that you can find on my Instagram page if you're interested, Vancouver. So, yeah. Yeah. You can find all those on the Instagram. It's just IG, yeah. Del got it. How do you keep objects from moving? Is a sample fixed in some way? Asks Ultramark. Yes, they are dried onto the covers, onto the stub, so that's basically going to cause them to be stuck on it, and then they are sputter coated in gold, as Del mentioned. So they do lay down a little differently when they don't have clay on them. So yeah, most of the big diatoms don't want to show themselves, and this one, I just got lucky, I guess. Everything's looking good. The word phage was auto-blocked? Well, that's weird. You know what? I got the word Rafi blocked when I tried to type it. I was like, what? But it is a sex term. It's just not one that people would normally know. So, you wonder what a pile of diatoms would taste like? Well, probably like algae. Carbon coatings, yeah, on we use gold, but or silver, but carbon will work. If somebody got that SEM command in, there you go. Sarah Dance Painter, how you doing? Somebody give a shout out to Sarah, would you? Strafey ends look like a noose. Oh, a nose. Sorry. Oh, they do look like a little nose. It's like a mouth and his little nostrils. It's a good point. Why am I a mod? I made a bunch of people mods while nobody was looking because sometimes I'm not able to pay attention to chat, and I figure if you hang out here frequently, then you should be able to get rid of junk that people post that I don't want to see, because you probably don't want to see it. And I find that people in the chat are exposed to things for much longer time than I am as a result of, you know, me not being able to focus on it. So this is the central nodule, and it does look like a nose. It's like a little nose, and he's got stripes on it. And we just draw a little googly eye there, put a mustache on it, and then comb mouth. Perfect. Okay, let's, while we're here, take a look at the ends, the Rafi ends. You know, this is the thing on here when I'm looking at something, I wish it would settle down, is that we usually look at the central area, the central nodule, I mean, and then I spend a little bit of time looking at each one of the poles. So each one of the apex where all the interesting stuff happens on a diatom, and then the middle stuff is just the middle stuff, you know. People don't even care to look at it, except for in an overview or a pretty picture. So there's nothing exciting going on there but Rafi and Stry. Okay. Mod only chat. That's fine. We'll just mod all the people. I'll give everybody a sword. I don't care, you know. Well, it's only noble if you're not just trying to use the mods to kick you out for no reason. So we're at 70 viewers though, so you're not all mods, you know. Yeah, this is my plan. If I put enough mods in here, everybody has swords, then something will come in here and start spamming crap, and it'll just be blasted to smithereens by one of you people. Sword chat. Oh, Pandemic Watch, you don't have a sword yet. I'll fix that one of these days. Alright, so we have new followers, and I didn't mention them. Bazizo. I like to just try to get the names right, you know. Basement Jeff. I mean, I used to live in a basement, and my name is Jeff. So, oh my goodness, this is a hard one. Morotsny. Yeah, that's a Morotsny. Morotsny? That's a long name. Ekim the Brave. Hey Ekim, thanks for the follow. DJ Mix It Up says, just your handle. Yeah. What are we looking at today? Oh, what was your Instagram? You just type IG. Bloop, bloop. Bloop like that. Boom, and it pops up like magic. This little robot tells you you can go visit my Instagram page if you like. You could also, if you want, join our Discord. And I haven't seen anybody do that yet, so I'm just going to put that in there. I do have a Discord. I sometimes will post pictures from the stream in both Instagram and Discord, because some people don't have Instagram or whatever. Also do sometimes post some of the things on Twitter if it's fun or it's a diatom and I feel my diatom colleagues would like to see it. sometimes I'll stream into Discord, either from the SEM or from my home microscope, or sometimes I'm just like drawing or doing the Photoshop-y stuff with the figures. So you can check those out there as well. It's a nice Discord. It's got a good community, you know, moderate sized. So we had a new follow from iGamer. Thank you for the follow. Yeah, many people from the Diatom, or the microscope streaming squad from Twitch are also visitors, regular visitors on my. This is the foot pole internal. It's a nice view, actually. Let's do the head pole, and then I will move on to something else. We'll stop focusing so much on this one little weird guy. Well, big weird guy. And it's pretty weird, so I feel like it's justified. I mean, it is a unicorn. I feel like when you find a unicorn, you ought to just stop and get some images of it. Because when are you going to get a unicorn again? I mean, I guess I could just put the sample back in, but I hear something talking. We got another follower. It's Ultramark. Thank you, Ultramark. Another cool diatom. Where's the horn? Oh, this is the inside view, Alpha Bio. So what the horn is actually like on the back side of the image that we're looking at. And DJ Mix It Up, thanks for the follow. Also, thanks for engaging in the chat. Yeah. Another follow. Thank you for that, MSG. We're really closing in on 800. 800 followers almost. Like a week ago we had 700, and like 3 weeks ago we had 600, so. DJ Mix It Up asks, how much is an electron microscope? Well, they have little desktop versions that you can get that are, I think, $75,000. So pocket change, and the one that we have here costs $160,000. Because they want to have one. I mean, I can understand why you'd want to know what the cost is. They're thinking, could I get one of these? Well, if you sold your house and you lived inside the SEM, you probably could get one. I don't think that's responsible, though. Oh, really? Hey, Shivank, how you doing? You could probably get some used. This sort of desktop type are a little more rugged, but they also don't have quite the resolution. And I mean, they're smaller too, so they would actually fit on a desk. But they don't have EDAX. And if you get them outfitted with EDAX, like ours has an elemental analyzer on it, if you're going to use it for that and you're going to get EDAX on it, it costs almost as much as one of these. So you might as well just get the full-sized one in that case, so you don't have to worry about the little chamber size and stuff. DJ Mix It Up says, how far out can I zoom? Basically, at the largest distance I can get away from my sample is something like 60 millimeters. And as a result, I can kind of get about 5 or 6 millimeters of field of view. Right now, our field of view is 19 microns. So it's hard to zoom out very far in the scanning electron microscope. You know, we can lower the magnification quite a lot. Like in our current view, we're not as close as we could get, and we're not as far away as we can get. We're somewhere in the middle. We're at about 15,000 times magnification right now. And if I, at this working distance, which is about 5 millimeters, if I zoom all the way out, so I'm doing that right now. This is our entire field of view at 5 millimeters. I have a 2 millimeter field of view. So, and the lower I make the stage, the farther out I could view. But the magnification rate here at 5 millimeters working distance is about 138x. So you could get that with a stereo microscope pretty easily, or right on the border of, the edge of a stereo microscope's maximum field of view, maybe. I wanted to zoom in and look at these little peanut-shaped guys because we looked at peanut-shaped guys before, and it was a different one. And I know that Pacific Plankton's here, and she likes the peanut-shaped ones. I'm currently working on this one. Is what used to be called Campylodiscus and is now called Cerarella, because they decided that there wasn't enough to distinguish Cerarella from Campylodiscus. And so the normal distinction that people used to make is that Campylodiscus would be wavy. Oh no, not Campylodiscus, sorry, Cematopleura. It was that Cematopleura would be wavy, and there was also some Cerarella that were wavy, and so they decided to look for some other features, and something to do with the canal raphe shape and these little windows that go into the canal raphe called the infundibulum. That's a crazy name, but they decided to use that to classify things, and as a result they got rid of Cematopleura entirely, and they dumped them all into Cerarella. So this, or Ichinella, but I think this would be a Cerarella. Not positive about that. It doesn't look like there's a little windows. So I'm going to slow that down so you can see the little tiny pores that make up the striae on the valve face. And then these little things are called fibulae. There's like struts, and the raphe's up here on a keel around the backside of this thing. This is an internal view of the diatom. And in the case of Cerarella, the raphe runs around the outside margin of the diatom, so they're called circumferential raphes. In other words, around the circumference of the diatom is where the raphe goes, and it's this sort of little bump you can see underneath the fibulae. Kind of neat. Benthic diatom, usually they live on mud surfaces, or what we call epipelic diatoms. Can you compare how much they cost with 10, 20, 30 years ago? Probably the quality's improved, but the price hasn't changed much. I don't know. But the little desktop versions that they have are substantially cheaper than you could buy an SEM for before. I don't think you could ever get like comparable in price for the time, with cost inflation or whatever. But I think 60, 70,000 or whatever, those little desktop ones are affordable, not for an average person, but for a lab. Your scope white whale is a confocal. Confocals are cheaper than SEMs, I think. Maybe they're about the same price, actually. But I'd never used a confocal. I know they use lasers instead of light, but How long does it take to process one frame? Is there any way to have it play in real time? We are playing in real time. I think what you're asking, the scanning speed is controlled by me. As the operator, I can determine how fast it scans, but then the image quality is influenced by the speed at which it's scanning. So I will give you an example Billy Galaxy art here in a second when it's done taking this picture, because it's actually building the picture as it goes. I will give you an example of what the speed does to the image. So it's building the image. Here, it's building the image no matter what we do, because it's not using light. It's not using reflected light. It's using electrons that are bouncing off of the material, and it collects them at each point as they bounce, and then it scans across the surface of it. So if you want an image that moves like a video rather than like a picture loading from the internet in the 90s, then you need to speed up the beam so it's moving much more quickly. You're still getting an artificial construct. It's just that it's doing it much, much faster. But the problem is that it then looks like fuzzy. I don't know how else to explain it, but the quality of the image declines the faster it scans. So I'm going to close this picture and then I'll give you some examples. So right now we're on speed 7. If I put it on speed 1, it will look like this. So, and I usually would need to turn the beam intensity up at that speed to even be able to see anything clearly. So this is what speed 1 looks like. And if I move, it moves. It's basically redrawing that image pretty quickly. This is the highest speed, the lowest quality image that we could get at this beam intensity. And if I change the speed to 2, you can actually see it building as a wave, building it. So on 1, it's scanning so fast you can't really see it drawing the image for you. It's like a TV. Here it's like a security camera or something, where it's basically you can kind of see it drawing the image. And if I change the speed to 3, now you can actually see it moving as a wave very clearly through the sample. And if I change it to, let's say, 6, but you notice the quality improves the slower the beam goes. So on this scanning electron microscope, there's 10 different speeds, and this is 6. This is 7, where we were taking the picture, and at this image resolution, which is 1280 by 1280, it takes about 3 minutes to draw the entire picture at a speed 7. And if I change it to speed 8, it takes about 10 minutes to draw that picture. And if I change it to speed 9 and I try to take a picture, it takes a half hour to draw that picture. And if I change it to 10, it takes an hour and a half to draw one picture. But the resolution is superb, right? So, that's the trade-off that you have to make when you're using a scanning electron microscope, is trying to decide, well, what's the image quality I want versus the speed I want to have to sit here and wait. Like, how long do I want to have to wait for this image? And because we're streaming, and I figure you guys don't want to sit through it, I usually take pictures at 7 when we stream. If I'm by myself and I find something really cool and I want to have a really nice image that I can post later for Instagram or show friends, or publish, more importantly, in a paper, then I will usually change the speed setting to 8. And I'll wait the 10 minutes for it because I'm patient and I don't mind waiting 10 minutes for a nice high quality image. If you got a bunch of diatoms on the field of view, and like this one, there's a bunch of Calanese. If you have a bunch of really nice images that you want to take and preserve, then it's kind of worth it to wait. 10 minutes now versus a you might never get that picture back. You might never find that diatom again. Then it's kind of useful probably to wait it out, and you just have to be a little bit more patient. I know people watching a stream probably don't want to sit through a speed 8-10 minute photo every time, but I usually won't go any lower than 7 unless I'm just trying to snap a quick picture of something so I can preserve it, or if I don't think that the quality would be substantially better if I switched it to 6, or worse. So yeah, the resolution lowers, the faster the frame rate. So Chilla Frilla, what are we watching right now? Right now we are looking at diatoms from Lake Tanganyika, just like the description suggests. The diatoms are a type of algae that live in lakes and rivers and oceans and any kind of water environment, really. So you see, Pacific Plankton's taking on my questions. Thank you. Look at that. So, Shavank, one thing I've always wondered with changes to classifications, how does this work? Is there a governing body that makes a final call, or just an agreement between major researchers in a field? This is a good question. So if you're asking at the genus level, how do we decide what's a genus and what isn't? Usually it's through peer review, and then whether or not the scientific community accepts that change. So I was talking about how Cematopleura has been dumped into Iconella and Cerarella, but if I keep calling it Cematopleura and I keep publishing it as Cematopleura, then and nobody corrects me, then it might end up that people just don't agree with that decision. More likely what will happen is they lump it back into Cerarella, and then later on somebody will come back through and find characteristics to separate out the Cerarella a little bit better, and they'll make new genera. So, they'll sort of collect them back in where they think is the highest taxonomic relationship that they can manage, and as long as there's a genetic rationale for it, they will keep them there. But if there isn't, and they can find that group is not monophyletic, they'll split it up into smaller groups. But the decisions are largely made by the community at large and how they apply it. So peer review process, and then also whether or not something is accepted by the community. And there's some things that are still contentious. So for example, there's diatoms that are called Lindavia by people in North America that are called Pantachekiella by a lot of the researchers in Europe. And it's because they just have different levels of confidence in the name for it. So they've decided in North America that they don't like the genus Pantachekiella, and I'm mostly in that camp. But there's people that have accepted and embraced it. So, as a community, it just sort of sits there. I'm going to call this the family photo, because it's just a little collection of stuff that I thought looked nice together, compositionally. Let's see. So it's a lot of sort of community dynamic, and I don't know how else you would do it. There's not really like a stratigraphic code group of people that are like, you have to do it this way out there. See, this has got that little slit-shaped. There's a lot of these things, I don't know where they belong, but I don't think they belong in Gomphanema anymore. This thing and that other one, the stigma is wrong for Gomphanema. And I just don't think that anybody's moved them yet. So maybe as a cluster, they need to be separated. What a cool little guy. Look at this cool little guy. Look at his cool little areolae. They look like wiggly worms. This is an Encynema. Pretty sure. A weird one. Let's see. I'm gonna go with 275. Oops. Move me over onto the sponge spicule. $265. Could use a little more. There we go. We're going to put our little football in the field of view so you could see the cool, very cool little areole coverings that it has. It's a member of the Wu-Tang Clan. Huh? Ah? It's got Wu-Tang. Okay. It's either Batman or Wu-Tang, one or the other. Okay. And beam intensity is way too high. Still feel like I could turn it a little farther. There we go. Old dirty diatom. Just fixing the brightness, and then I'll come check out the channel, see what you had to say. Really love all these diatoms, and they're really cool pore coverings that we've been able to see in these samples. Just spectacular. You know, when you see them in the light microscope, that's just a little line. You know, this makes a line and that's all you see. It's really nice to be able to see them clearly with no mud covering them. These cool little mouths on the outsides of the holes. We'll do it. That's a good one. Let's see what people are saying. Probably we won't have any SCMs in people's homes. Experiment was a failure with your confocal, but some other people in the lab were wizards. This is an X-diatom. It is no more. Yeah, they're all dead. It's okay. Have I ever tried 3D renderings? I have. Using an SCM, actually, to draw them. So I keep meaning to show that one of these days. Maybe I'll show some pictures in the Discord for you, Sarah. This is a good question. Yeah, set it to 10 and take a break for lunch. That's actually what I do sometimes. I've set it on 9 before, and then left for lunch. And actually, picture was pretty amazing. So, Tropical Geek, how you doing? Look, I gave you a sword. Yeah. I don't know what you mean, Alpha Bio, because I can't catch the thing on the left. I think it passed already. I give you a sword because you're always in here, and then you find some people doing bad things, so you can stop them. Is it something you can do as a batch operation? In other words, let a batch of 10 quality images be scanned overnight. You can set up some sort of automation on it, but it's another software program. So, Del Max says, sorry, I got a lurk. Another freaking outbreak. Don't worry, Del. Thank you for hanging out, even if you got a lurk. Who are my peers? Well, there's some in the channel. Eva and Luhan are both peers of mine. You miss Mallory? Well, you could hang out in our Discord. She's there sometimes. You probably wouldn't get to see her, but you could get to write messages back and forth. This is water. We started with water, actually, yeah. Del's still here. Batang. Who is Wu-Tang? Come on, Tropical Geek. Get with the program. We can't look at water itself, but these are things that are found in water. Nobody's ever seen Batman and Wu-Tang in the same room. It's a good point. Yeah, they're smaller than a tip of a toothpick, for sure, Solar Mander. These are really tiny. Okay, look, I almost caught up, and now I've got to go back and fix the SEM. Okay, we're going to put this down as Ensynema Wu-Tangii. Ensynema Wu-Tangii. That's not its real name, but I'll remember what it is that way. You know? That's the important part, is that I remember what it is. Not that I put the right name on it. Later on, I can put the name on it. In fact, maybe put a name on it. I don't know. Could be one that I name. We haven't started looking at the Ensynema yet. This site's sort of a hotbed for Ensynema. Also, what was that? A Navicula? Huh. Look at this cool little guy. Look at this crazy little Rafy ends. Lineolate striae is a Navicula, but he's got little knobs on his ends, on the valve ends. Little handle. Let's see. There's like a whole bunch of diatoms in here, and most of them are Calanese. Some Nitzia, some sponge spicules. Somebody asked me about a long skinny thing. This guy again. That's a different one, but it's another girdle view of the unicorn. What's this? Oh. Gonphonitzia ungeri. Gets a little capitate when he gets big. It's interesting. There's a little Stephanodiscus, and here's an external view of a Celophora. There are a lot of really cool Celophoras in these samples. I think I've mentioned that in a previous stream. We're probably going to focus on the Celophoras when we get done with the Afrosimbellas and the Diplonese. I haven't seen any Diplonese in this sample. But my friend Itzi is a Diplonese expert, so she's got a whole bunch of new ones she's working on describing. We saw these ones the other day. Like this really cool little internal structure on the pore openings. Not with beam intensity 10, we can't see them. But now we can. Right? We saw these like really cool structures on the inside of this Placanese. Oh, we weren't quite as close to the other one. We're somewhere out here, but you could see they were like little diamond shapes. Okay. So I can't even believe it's almost 3 o'clock. I've been lost in this little microscopic world for almost 2 hours now. And the time has just sort of blown by. You know, I really need to get back to the other slide. So I'm going to do that now. And see if I can get that thing I started looking for when we set out on this journey, which is actually an Aphrosymbella, and there was one way over here somewhere. One of the things that you get good at in the SEM world, if you're using an SEM a lot, is sort of building a mental map. But one problem is that I sometimes will rotate the stage and then and where I thought something was is like, oh, that's not where that actually is. That's where it was when I had the stage rotated. So I recall it being over here. Yeah, good. Also, what is this? Not to get distracted in the middle of my rant about not getting distracted, but it's a Nidiopsis, maybe? We haven't seen one of these. It's either Nidium or Nidiopsis, I think. Is this structure out here on the margin kind of suggesting that? Also, this one has some pretty cool pore coverings as well. Again, little star shapes and clover shapes. Yeah, I think it's a Nidiopsis. Let's take a look at this. Nope. That is a Symbella. It is not what I was looking for. Well, it's a good thing I came back to look at it. So now we're free to go look around some more. Oh. That's an Aphrosymbella, though. For sure. So the way that you can tell Aphrosymbella is the stigmoid, whatever, is slit-shaped. It's always on the dorsal side of the valve, so like a dolphin, the back, instead of the belly. And then it's asymmetrical. So you can see that this is not quite perfectly symmetrical, hopefully. And going to just set the speed so I can position it a little bit better. feel like the focus is still just a little off. Oh, it's because I'm on beam intensity 10, of course. Looks good. Now I can go back to try to catch up with chat again. It's like the never-ending race to find the bottom of the chat list. Let's see. Hey, Lophius Dragon, how you doing? It's nice to see you. On holiday mode already, yeah. I wish I was in holiday mode, but I don't really have one except for the part where I eat cookies. How small is the tip of a toothpick? Freya's Fury asks, I wonder why diatoms evolved to make those many weird shapes. It's a good question. I mean, I think in most cases it's form and function. There's like a reason for it. In the case of these, you know, particular diatoms, the foot pole, head pole thing allows them to attach and probably make a little bit more space at the bottom, which is why they're probably asymmetric. I mean, the different types of coverings, I have no idea. I don't know that anybody knows why they make the different types of coverings, but it is how they communicate with the outside world, as Pacific Plankton mentioned. Icy Yoga, this is diatoms in a scanning electron microscope. That's what? If everything was just ovular. You love naviculas? Oh, they're pretty cool. I like putting mustaches on diatoms. Is the background glass? No, in this case the background is aluminum covered with gold. So they're little aluminum stubs. So what you're looking at in the background is probably a little bit of clay or something, and then the surface of the actual metal stub that they're attached to. So, and coated with gold. That was like a half-chord pear. Are there any algae classified as macro? There are macro algae. You know, there's a bunch of large algae in marine settings that are things you could pick up that are still classified as algae, like Penicillus, Eudodia. A bunch of the calcareous algae are like that. Are these alive? No, everything in here is dead. It's in a vacuum. I am at work. Icy Yoga, this is my lab. Yeah. They're dead and coated with gold, yeah. It's nice that he's allowed to stream this and share it. You know what? I'm in charge of my own lab, so it is nice. I did also check with my chair. She's fine with me doing it. But it's my lab, so I can stream what I'd like. Hey, Ultra Mark, thank you for subscribing. I should point out that I don't make any money from subscriptions. I put all the money that come in back into my lab to pay for student research or to buy supplies that were used during the stream. So all my university's SEM and TMs ran on Windows XP. Yeah. Everybody complains about my Windows 7, but you know, at least it's not XP. If I had an SEM, I'd never get anything done. Well, I have news for you. I almost never get anything done because I'm staring at stuff in the SEM. So that's not totally true. My work is my SEM work sometimes. So yeah, the seaweeds are considered algae, some of them. I have a calming voice like Bob Ross. Well, thank you. I wish I had a pet squirrel like Bob Ross. I got a little pocket in my, you know, hoodie. I would just keep it in there. I would hang out with the squirrel. Happy little diatoms. Yeah. I get that comment a lot. I think it's because I use my golden voice whenever I'm on stream, trying to talk relatively calmly, but also into the microphone. So, can I show you the machine and how it works in some other sessions? I have, and I will do it again. I can maybe, yeah, at the end of the stream, I can back out and show you a little bit of the scanning electron microscope if you'd like, Ultramark, or Icy Yoga, sorry. Will the stream be available as a recording after the live session? Yes. All of my streams are kept here on Twitch for about 2 months afterwards, so you can go back and catch dozens of streams if you like from the SEM, and then I try to also archive some of them to a YouTube site, but I haven't really published the YouTube site link very frequently, so probably I should. Following me on Twitter is a good way to catch me as well, and thank you for doing that, Alpha Bayo. And I do a lot of photography, so you'll see some stuff from the stream on there, but you'll also catch my astrophotography or macro photography on occasion, or birds. I do a lot of pictures of birds as well. So I think this guy is Afrosymbella Muelleri. Pretty sure that's what this one is. It's one of the ones I was hoping to find today. It's the internal view of Afrosymbella Muelleri. I really wish I could get a nice external view of it. Maybe it's not in the cards for today. But let's see. Some tricks that I like to do if I'm looking for something is to get, okay, I can tell that's definitely Afrosymbella Muelleri at that scale, and then I won't play with the scale, and I'll just move around and try to see if I can find something similar, you know, in terms of size, that's the right shape. So it's actually really challenging. It's easy to get lost in the scanning electron microscope world, both in time, but also in the landscape of what you're looking at. Oh, I want to stop and look at this one, though, because I think this is another Afrosymbella. I think this one is Ashurani, something like that. It has the characteristic components. You can see it's got a slit-shaped stigmoid. The raphes are similarly sort of antler-shaped, and the only thing that's kind of not clear is whether it is asymmetric enough to be an Afrosymbella. And so usually it would have a slightly dorsiventral shape to it, and this one doesn't. But there are some examples of people that have lumped stuff into Afrosymbella, and they weren't very asymmetric at all. So, you know, that's a question mark for me as to whether this is actually an Afrosymbella or not. And I need to run it past my friend Itzy, as she would probably have an answer. I'm working with her on this project, so... But some of these things that we imaged today, probably I will send to Itzy and see what she thinks about them. And then we can make a decision about what we should do with it. So... Sorry, I'm just going to get the brightness correct, and then I'm going to take this picture and I can jump back to chat and see what people are talking about. I've got about maybe 15 more minutes before I want to end, and I'm going to spend probably 5 of that showing you what the SEM looks like from my phone. So I can maybe get 2 more pictures in before we probably should end the session. It's going to be a nice one. I say that a lot, but look at all those My Instagram is fire. It's pretty cool. My actual Instagram is pretty nice too. I have a separate Instagram besides the SEM one that's got a bunch of cool images on it. You can find it through the SEM link if you'd like. So let's see, we've got new followers. Icy Yoga. We got the subscription from Ultramark. Thank you for that. Ad Manta with a follow. Astro Canuck with a follow. And Kelvin Simulator, who I see just made a comment in here. Cool Images is also given a follow. And Solar Solar Mander, like Salamander, but with the sun. Thank you for the follow. So, cool lab I own. Yeah, it's actually one of 2 labs that I'm in charge of. So, the other one's pretty cool too. That's where all my people sit usually, and also where my microscopes are, my light microscopes. So, you came on Twitch to watch people play Valorant, and you left with interesting science. You know, Ultramark, Valorant's pretty interesting to watch. I like to watch people play too. One of our friends of the channel actually plays Valorant pretty frequently. So, I know how you feel. But I'm glad you came and hung out with us. How many papers did I publish this year? 11? But I wasn't the lead author on all of those. And I've got like 4 in the chamber that are working their way through revisions or are in gallery stages. I don't think they'll get out this year, but it means probably we'll have a pretty good year next year as well. So looking forward to that. SEM ASMR. I don't know, you want me to like make noises? Or just talk? It's my normal voice, really. Especially if I gotta talk for a long time. So, yeah. Admanta, I agree with you. Diatoms are just absolutely beautiful organisms. Unquestionably, one of the best looking microfossils in the world. And they're super diverse. They're incredibly useful for reconstructing environments. And they're informative. They can be used both chemically and ecologically. And, you know, it's a... Oh, Pacific Plankton, you gotta go? Okay. Have fun hanging out with your family. I'm sure that's what you're up to. So it's probably lunchtime for you. You'll catch me later, I'm sure. I got your samples in the other room, Pacific Plankton. I'm going to probably look at those on Saturday. So I got 1 sample at least should be done. This is tremendous. I love it. I usually image in the opposite direction. Oh, like super large. Yeah. Space. I do that too. So probably not as well. Kelvin Simulator. I used to work with the TEM, cryo, and 2D crystallography. Man, I wish I had a TEM. Those would be amazing. I would stream if I had it. If I had a TEM, I just don't have the $500,000 it takes to get one. Especially if you got a cryo. Those are pretty neat. So I love seeing people geek out over science like this, looking into the infinite and infinitesimal. That's how I feel about it as well. I like looking at really small things and making them available to people. So with my camera, with my light microscope, with my SEM, basically it's always the same thing. I like to take the invisible world for people and try to explain to them, you know, by pictures, why they should care about it, what's interesting about it. And for diatoms, it's easy because they're just gorgeous, right? You don't have to think too much about like, hey, you should like this thing. It's got interesting textures and it's cool to look at. You know, it's obvious if you're looking at them and I guess if you have a soul, that they're pretty interesting organisms. And not necessarily a religious soul, but you know, like, it's something about it should speak to you, and hopefully it does, or you wouldn't be here. I mean, unless you just like my hat or something, which I'm fine with. But yeah, that's what I like to do, and I think my peers often wonder why I do stuff like this, because it's a lot of extra work. But I actually find it's really important to talk to the general public about science and give them a different idea of what scientists are like. Everybody has unless you're friends with a scientist or you are one, you probably don't have a very good idea of, what scientists are like. A lot of us are just kind of normal people. Usually pretty bright normal people, but daily lives are controlled by the same thing as everybody else's. So there's a bunch of cool people that are on Twitch that have made it a really nice community for me, and I know that Dell and Pacific have been in and out today helping with moderating the channel, and I want to especially thank them. Two of my closest Twitch friends, and I almost always catch their streams, and they're not streaming anymore this week I think Dell's going to stream on Saturday playing chess with his wife, but I think Pacific's done until probably sometime next week. And this spiny thing that we're looking at is not a diatom, by the way. So I want 35-degree rotation, something like that. Let's see. Too far. 25. Let's come back about 10 degrees. This is actually a sponge spicule. So sponges, freshwater sponges, people, not the kind that you wash your dishes with, the organisms, they make these silica spines, and they tuck them into their skeleton to the outside of the sponge so that things won't eat them. And you probably don't want a mouthful of this. If you're at the size where you could eat a sponge, you got one of these in your teeth, you probably would rethink it. So they're called spicules. They look a little bit like a toothpick. A lot of them aren't quite this spiny. This one is particularly spiny. Just to show that we're equal opportunity SEM users, I am going to take a picture of one of these as well. It's not just diatoms on the channel. Diatoms are what I'm presenting recently quite a bit about because it's the thing that I specialize in. But for people who are tuning in who may not be familiar, I do sometimes put other things on the stream, like mushrooms and flowers and pollen, phytoliths, insects of all sorts, butterflies, scales, and centipedes, and mites and ticks, hair, anything that's small, we'll sometimes put on, and more frequently when my lab assistants are around, we'll have fun things and focus a little bit more on those. Oh, cyanide teacups! Hello! It's my good friend Cyanide Teacups who's shown up, and she subscribed 4 months in a row. I've only been on for 4 months, so she's been here for all of it. And you should check out Cyanide Teacups. She's a fellow streamer, and we like to, she doesn't stream the same time as us very frequently, but usually when I hang out with Pacific Plankton, when we're done with our stream, we go for a raid. We raid Cyanide Teacups. She's usually playing cool video games, and she does stream captains, and she's sometimes doing 2D Minecraft pixel art, and she takes requests. So you should check her out. And now that I'm taking this picture of a sponge spicule, I'm gonna give her a little shout out in the channel. Cyanide Teacups. She's just a very pleasant person. And you'll have to raise my game and bring back more science to your channel. Well, You do whatever you like. It's your channel. But I'm happy to watch more science. Let's see. Sorry, just scan backward to try to catch what I missed. So, another subscription. Thank you, Solarmander. A join and a subscription in the same day. Let's see. Oh, and we got an emote out of it too. A Christmas emote. Thank you for that. Hopefully you enjoy all the Diatom emotes that you got by being a subscriber. So, Titan and the helium, yeah. Dell, you're gonna run? Okay, thanks for hanging out. And as always, we'll catch you later. So, please more every science field for stream. We're working on it. I can only stream so much. You can see there's really interesting streaks on that image from the spines themselves, the little spine peaks. Wait, what happened? You gifted a sub to Solarmander? Oh, Solarmander gifted out 5 subs. Oh, I see. There's a whole bunch of gift subs going on. Thank you for that. That's super impressive. As I mentioned, all the money that comes in through subs, I give it right back to my students, or we use it to help pay for the supplies that we use during the stream. So, thank you for supporting us. I really appreciate that. And in January, when the kids can come back to the lab, it will be nice. You can hang out with Mallory and Rihanna and have some new students coming in, so maybe they will also help us out. So I'm glad you're here. And also, Astro Canuck, thank you for the compliments. Let's see. Yep. And thanks for all the follows as well. Today we've had a whole bunch of follows. We've had a pretty full channel in here for the whole day. And a lot of really great questions. So I want to say thank you to everybody for hanging out with us. And I really am trying to catch up. It's like I'm trying to read while this is scanning, and there's so much stuff going on. Oh, we have tried to look for those X metrics, the little mites that live in eyelashes. We did a whole episode where we took everybody in the lab's eyelashes out, and tried to more subs. Really, thank you for that. Sponge spicule. You can see that the SEMs create some sort of little artifacts around the spines on that. We tried to do that demo decks. We did a search for it, and we even collected some from old people, old professors around the department. Mallory awkwardly wandered around asking people, "Can I have some of your eyelashes and eyebrow hair?" For which I'm very grateful. You know, she does whatever I ask her to do in the lab, including asking her fellow professors for their eyebrows. Not all of them. We just needed one hair, but we got a lot of eyebrow hair donors, and we didn't find any demo decks on any of them, which surprised me. I was really hoping I was infested, but the longer you live, the more likely you are to be infested by your eyebrows are, or your eyelashes are to be infested by them. So hopefully I'll live long enough to get infested, to have my own little community of eyebrow mites or eyelash mites. But I didn't find any this time that we did that. We did go looking though. I tried in the light microscope before I tried in the SEM, so I gave it a college try. That's all I can say about that. I did try to do it, but we didn't find anything. And I was disappointed. I really thought some of the old people that we had checked out would have been likely candidates for it, but nope. No dice. So I'm going to jump back over. Now that we got a picture, I feel like, you know, a little bit more comfortable now that we managed to get the one thing I was hoping to get a picture of in this whole mess. And maybe we can get a couple more views with maybe another external shot of one of them. That is Ensynema. That is Epithemia. That's a Nitzia. There's a whole bunch of diatoms in our field of view here. And I'm really just looking for one kind in this mess. So Slophras, these are mostly Calanese and Rhopalodia. Or they're now Epithemia, but were Rhopalodia. Here's another one of these. We saw one of those, but I didn't think it was very good. I wonder if this one's better. Oh, that's a Calanese, actually. Rhopalodias. I really want to hop back to the channel and see what's going on. So it's always this sort of like struggle to find something that I want to image and then also manage to get back and see what people are chatting about. It's one of these unicorns we saw. I can't believe that everybody is giving me so many subscriptions to the channel today. I feel like you're in the... Somebody out there's in the Christmas spirit. You know. Thank you very much for that. And I'm going to recognize you as soon as I stop to get a split second where I can actually like find a diatom that I want to image. Oh, that's a pretty good internal view of that thing. If I didn't spend the entire first part of our stream looking at them, I would go back to it, but I feel like I've just dwelled on it a bit too much. Let's zoom in and look at this Rhopalodia. Oh, there's also a Gomphanema up there. Rarg! It's a good looking Rhopalodia. Epithemia, whatever you want to call them now. You can really see the raphe, the circumferential raphe, or the keel raphe on the margin. Sometimes not so easy to see. Beam intensity is too high because I've been scanning around. Okay, it's a good one. It looks like a happy face, yeah? Or like a set of those clacky teeth, you know, that you wind up. You know what I'm talking about. I'm sure. I think it's good enough. We'll take it. And then I can see what people are doing. Okay. Let's see. My stream is doing jigsaw puzzles on the 25th. Oh, cool. You know, the only problem with that is I'd like to help by putting pieces in, because I like doing jigsaw puzzles. You do not regret this click one bit. Thank you, Astro Canuck. I don't regret you being here one bit either. So, let's see. I finally caught up to the part where cyanide came in the channel. Let's see. These are dust-sized particles. What do I usually stream? Oh, Kevin. Okay, that's for him. A fly's eye. We've looked at a fly before. Let's see. Let's see. Thank you for streaming your work. I love that more people are streaming sciences. It's amazing stuff, and we don't get to see it in our normal day-to-day. Well, you're welcome, Solarmander. Let's see. You try to stream regularly old horror stories and then play a related game. Well, that's a pretty cool idea for a stream. Oh, one of these days you're going to make a diatom on Minecraft? Oh, cool. Okay, let's see. What did I miss? Oh, there was a gifted sub to Pandemic Watch. Thank you. Pandemic's on the Discord, by the way. And a gift to Mama Bon Bon. Well, that's definitely not a wasted gift. She's in here all the time. 25. Holy cow. That's a lot. That's a ton. All right, Solarmander, thank you. That's amazing. And everybody gets to use the emotes now. And 5 more. Oh my god. I don't even want to know how many subs we're looking at for today. Magordito. What is that? It's a diatom. We're looking at diatoms today. Post-publication peer review live. Oh, that's a cool idea. Sometimes I do interviews, I should point out, with other scientists. If they have a publication and they're a friend of mine, I'll sometimes invite them on to talk about what their publication was about. Relatively uncommon, but I'm still working on making that grow a bit. So I wish I had time to stay and ask questions, second shift calls. Big, Chewy, Failson, you can always catch me later or jump onto Discord and ask questions there. So that will also work. Light. Lash mites. Let's see. Yeah, all right. Great. Awesome. Great job. 7 out of 10. 7 out of 10? I feel like that's not even, that's like a good job. All right. I'm still trying to catch up. There's some more gift subs that came through. 5 more emotes were shared. There's so much stuff going on. What is Gyoza? A diatom panini, I would agree with. Yeah. It's a mouth for the nose, I found. I should put a diatom face together. That's a great idea, Luhan. What is a gyoza? I'm not familiar with it. It's like a watermelon slice, yeah, for sure. I have a fly on Instagram somewhere. There's a bunch of stuff on Instagram. We put a lot of that stuff out there, so... let's see. Thanks for streaming. You need to go. Happy holidays. Thank you, Luhan. You have a good holiday, and we'll catch you later for sure. So, I'm actually at the bottom. I made it to the bottom of the list. Okay. Japanese dumpling with pork in it. Oh, that sounds good. You know what? I haven't eaten lunch today, and it's 3:30, and I feel like I should do the little. Somebody asked me for a little tour of the what the SEM looks like outside of. Because you're just looking at what it produces, and Ropalodia. And I can do that. And I'd like to, I'm just going to find one more thing, promise, to image. And then while it's running that, I will hook up the old Droid Cam to my phone and then share that with you guys so you can kind of see, because you've been looking at, hopefully you've been watching the stream, and you've just been seeing what the SEM produces, but I can do like a quick sort of tour. And then one of these streams I'll probably spend a little bit more time just sort of focused on the SEM. I've done that before. You know, we've had some streams where I sort of showed the whole process of collecting samples and all the way through to imaging and like how, like what we see and the sputter coating process as well. So I have done that before, but you know, it's been a while. So let's see, maybe 320. I got that perfect on the first try. So we're just going to make it we're going to have a nice, pretty Afrosimbella or Gomphanema, some type here, and I just need to get it a little farther out so you can see it easily. That one's definitely Afrosymbella. So slit-shaped component, the antler-shaped raphe ends, and this one's a little bit more asymmetric. You can see it's got a dorsal-ventral difference. And I will put that on speed 8, which is a little slower. It looks good otherwise, and I'm just going to set the brightness and contrast, and then I'm going to do a quick tour so you can see the SEM and where I've been sitting, and a little bit of the lab. The only problem is, of course, I'm sitting real close to the microphone talking, so you probably won't be able to hear me very well if I move around too much. This looks good. Everything's looking good. I might actually lower the beam intensity just a little to improve our resolution. And I'm going to snap that picture. And while that is drawing and you are entertained by that developing, I will droid cam my phone. Real quick, like. That number is correct. And I will leave the audio on the main mic instead of on my phone because I don't think it'll sound very good through my phone. Let's see. That's right side up. Okay. So the droid cam is working. Let me switch to OBS and do a quick transition. Then we'll come back to the image that's drawing, and then we'll find someone to raid. So, okay. So this is the actual setup where I've been sitting. There's two monitors. This monitor goes to the elemental analyzer. So earlier I was doing a little bit of elemental analyzing. You can actually see that it can spit out the chemistry of a sample. This is a sample that I was working on from White Sands National Park, but not diatom related. And so this sort of thing is a whole big desk, is all the SEM. So you should be able to see all of it right there. That's a pretty cool view of it. And so the SEM itself has many different components. This is the chamber that we're looking into. This is the secondary detector that collects the electrons that come off of the sample. And this is an elemental analyzer that looks into the chamber that produces that image over there that you see with the spectral peaks. And this is like a drawer that opens. So when there's not a huge vacuum, the vacuum in the chamber basically holds this shut. But this is a drawer that opens. The samples sit on in a little tray on one of these little carousels that you can see right here. So everything that we've been looking at today has been on the head of one of these little stubs, actually smaller ones. They're like this size. So everything that we've been looking at in one of those circle views is basically the head of that. And so there's a couple of different analyzers on it. One of them, this is the little camera that looks into it. It's an infrared camera that looks into the chamber. And then there's also a density detector. So there's another thing besides the secondary detector. And then this is the Electron Gun is that silver thing that's right there that shoots down. The electrons get charged up in the top of that, the Weinhold cap. And they have a negative charge, and they basically get pulled down through this column. And this column right here is filled with magnets. And the magnets are used as lenses that focus the beam, and then hits the sample collected in the secondary detector, which then comes into the computer. So that's the whole of it. It's a little microphone I'm talking into, and the camera sitting on top of a 3D printed diatom. and a little speaker so we can hear some things occasionally. On this side of the lab, there is a little picking scope, and sometimes I use this document camera to help me show people when I'm identifying some samples. The little caboodle kit over there has got all of my prep materials, stubs and things in it, and there's some samples. That nitrogen tank is empty, otherwise it would be chained up. There's some sample stuff back here, and behind me a dry chamber where all the samples are stored. And then, sorry to make you a little bit dizzy, if we go back to this direction, you can actually see there's some samples over there that belong to my one of my colleagues, and that's a sputter coater in the corner back there. So that thing is the sample sputter coater that has a little gold foil target at the top, and gets charged up into a plasma state, and it deposits the gold on the actual samples that we use. And then this is just storage area back here behind us. So most of what you see in the lab space is for the SEM lab, and there's a whole other part of the lab that's around the corner that doesn't have anything of mine in it yet. I'm going to switch back to the field of view, get rid of the droid cam, so we don't have to fight with holding it and everything at the same time. And then I have a whole nother lab that's on the other side of the building where all of my light microscope stuff is. So in here we mostly keep stuff just in the SEM labs. There's a nitrogen tank behind the wall over there that is being stored as well. So hopefully you enjoyed that little tour of the SEM itself. My SEM lab is actually huge. A lot of people just stick their SEMs in a tiny little closet, and every time the SEM technicians come in here, they're like, whoa. Yeah, so it used to be a classroom, and they just converted it into a lab for me for the SEM. And then the whiteboard's where we just track all of our samples and the calendars and stuff like that. So hopefully you enjoyed that little tour. Let's see. I will always be coming back. I think on Saturday we're going to look at some samples that Pacific Plankton sent me from San Francisco Bay. So we'll move out of Africa for a little while and move into San Francisco marine diatoms. Yeah, thank you for the subs, though. I really do appreciate it. Is the microscope actually scanning right now? Nuff Lee asks. Yes, it is. That's the picture it's drawing is scanning as it's taking the image. And so that's a good question. A lot of people don't recognize that it's actually drawing the image as it goes. Let's see. I'm trying to catch up again. Oh, pot sticker, yeah. Astro Canucks and Diatoms attack, yeah. And I'll follow you guys after the stream is over and I have a chance to actually look through some of this stuff. These are the critters that make stuff we put on our goats. On your goats? You have goats? All right, gonna grab lunch. See you around. Have a great day, everybody. Thank you for hanging out with us, Kevin Simulator. Yeah, I get a lot of repeat questions. It's fine. Some of them I just put little things inside the bot to answer. I don't mind answering the same questions, and you know, it's good to manage. I have also went out over the weekend and I collected some water bear sticks. I don't know if they're going to have water bears on them, but I did stream myself hiking to the places where I went to collect at least one of the samples. And probably I'll do a little stream when I download the video, and I'll play it and talk over it. I didn't talk when I was actually hiking. You might hear me huffing and puffing a little bit, but then I was sort of walking around in one of the local parks before I collected some of the sticks. So a wide angle room cam would look cool. Yeah, I probably could put one in here. I have a wide angle camera at home that we were going to use for this for this stream, but I sort of use it sometimes also for teaching right now. So maybe when we get a little less stuck in the pandemic issues, we'll be able to do that. Thank you for following, Nuffly. So exciting lab. Well, I mean, it's an okay lab. I like hanging out in it. I sometimes hang out in here even when I'm not streaming or using the SEM, just to get away from everybody so I can hide. Oh, was there a distortion? I don't see any distortions in my image. Oh, I guess there is a little distortion in there. It might be from when I opened it. I probably caused the SEM to vibrate a little bit when I did that. So, it's a good point. I wasn't thinking about it. Probably ruined my image just a little bit, but that's okay. It's not that big of a deal. I can always take the picture later. Okay, so I need to find somebody to raid. We started off our stream today with a really big raid from Last Miles, and I want to really thank him for that. There's been a bunch of people that have followed today. We already broke 800 followers, and when I started today, we must have had 760, I think it's something like 40 followers today. That's a crazy number of followers. So, oh, I see. You had Diatomaceous Earth. Yeah. Got it. That edX is so tiny compared to the ones from 2005. Yeah, well, they are tiny. We got 800 people that are following us in 4 months, so that's pretty good numbers. And we've had a really great viewership today. It's been sitting around like 70 almost the whole day. So I want to thank everybody for hanging out with us, for all of the follows. I'm going to try to read a bunch of them. So recent ones that have come in here. Magor Dito, Big Chewy Failson, AA Carm, Siegton, Pixel Breath, Nuffly, Beer Bong 12, and Mindolator are the last couple that we've just gotten here recently. There's a ton before that came through. We've had a ton of great questions today, and now's the time on the stream where I should figure out like who to raid, so I can get some lunch and stop working so hard. I'm supposed to be on Christmas break, you know. So let's see. We'll find somebody that I follow who's online. All of my normal friends who are on at the end of my stream are also still on at the end of my stream. And none of them are in the science category except for Dr. Javasaurus. And we haven't rated Dr. Java in a long time. My other choice is probably Numb the Geek, who's a music streamer, and I torment him sometimes by making him live learn songs that I like, and he plays them. So that's pretty cool. Maybe we'll get to partner eventually. We'll see. I'm looking forward to hopefully doing that. If nothing else, so we could draw a little more attention to the microscope streaming community. So thanks to everybody for hanging out. I wanted to give one last shout out to my microscope streaming squad. Those are some people right there who will stream from the microscope. I would also add Spider ID, and there's a couple more people who are starting to as well, who are starting to stream from microscopes. And if you're interested in it, you should check them out. And also, if you have questions that I missed, which is definitely possible, I didn't catch everything, I'm sure, you can catch me on the Discord, and we'll be happy to answer questions there. Also, if you like diatoms and you think they're pretty and might want a t-shirt or something, I guess, I have a Redbubble site where I take a lot of the diatoms that we see and I draw them, and then we use that artwork for stickers and and mugs and t-shirts and things that you can get from Redbubble. They make it as you order it, so I don't feel like there's any pressure for you to get anything like that. And again, all the money that comes from the Redbubble site goes to the student researchers in my lab, so I don't make any money from that either. So I get enough, just enjoyment hanging out with people. I don't really care about the money aspect of it. Okay, so I didn't get any specific comments about who to raid. Maybe we'll go raid. Oh, Sarah Dance Painter just went on. I guess we could raid Sarah. Sometimes she sees me coming and then jumps over. But let's raid Numb the Geek, because he played a really cool song for me the other day, and he's one of my favorite musicians on Twitch. So, and I haven't rated him for at least a couple of weeks. So, N-U-M-B the Geek, and plays great music. You should definitely check him out. Hang out with us for a little bit as we jump over to raid him, I guess. And I think I got it going correctly. And I can put this over there. And turn off the web captioning. And we will go raid. Okay? I want to thank everybody, really everybody, for hanging out. We've had a great day today. I know there's... the holidays are coming up. It's sometimes a hard time for people. Sometimes it's a good time for people. I hope everybody has a great holiday season. And we will stream again from the SEM, I think on Saturday at 1 to 3 Eastern, sort of in that time frame. If my wife is okay with me leaving the house on Saturday, we'll probably do that. And then if not, definitely by next Wednesday, we'll do another stream. And we have something coming up with lizards soon, with Sarah Lasaurus, one of our friends of the channel, who also happens to be a PhD student here at Indiana State. Okay, great. Thanks everybody for hanging out, for all the follows, for all the subs, and for all of the great questions and dialogue. I want to especially thank Pacific Plankton and Del Maximum for hanging out and moderating the channel, and also all of my other mods that came in as well. So thanks everybody, and we'll go raid now. Thank you. Have a good holiday break.